Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So today we will be seeing about truth tables. So here is our problem statement. You can check it out. So for a boolean function of n input, there are two n possible input combinations. Each row of truth table lists out one input combination. So there are two inputs. So what is a truth table? It is basically like possible inputs and possible outputs, table of possible inputs and outputs. So we have to implement the logic such that it should the output should give one only for these things, like these input values. So how can we implement it? It's a very simple, it's just a one line code. So let's see how we can do it. Assign of f equal to, so check where is first one occurring in the output. So it's when x3 is 0, x2 is 1 and x1 is 0. Here 0 means bar. So what we can do is, so x, so as you know, we can do this similarly in using a K-map and simplifying the equation. But here is one trick that you can directly write this. Wherever there is a 1, you can write the number of inputs there, or number of inputs, like directly the inputs. So first one is occurring at when x2 is 1. So other three are inversion of x3 and x2 and inversion of x1. So or here we are using sum of products approach. So when is the next one occurring? When x2 and x1 are 1. When x2 and x1 are, so x3 bar and x2 and x1. Or so let's see where another one is occurring. When x3 and x1 are 1. x3 and x2, inversion of x2 and x1. So this is the last one in the output where all three are ones. x2, sorry, x3 and x2 and x1. So let's submit the code. So as you can see, compilation process has been started. So as you can see, the status is success and we have successfully implemented the logic of a combinational logic, and here is the timing diagram. So in the next video we will be seeing about something it is there. Let's see.